Hello, welcome to this segment of Geology Tour with Thomas. I'm Thomas Eckert, your tour guide. Today's topic will be hurricane fault. I'll explain in a little while what it is. We pronounce hurricane here as hurricane, not as hurricane. That's just a local quirk. I'm here at the Laverkin Overlook. In back of me you can see Zion Mountains, Zion National Park, Big West Temple. What is a fault? A fault starts out as a crack or fissure in a layer of rocks, like here the sedimentary horizontal layers of rock, goes deep down. In our case, it's a force which pulls the two parts apart. As a result, the left side or the west side is pulled a little way and starts sinking down. This is what's called an extensional fault or also a normal fault. The hurricane fault is part of the separation between the Colorado plateau, it stays high up, and the Basin and Range province to the west, which sinks and slips down more and more. How do we know that we have a normal fault here? There's a couple of things. The layers in this nice mesa have been built up over time. As we turn around, we see again Zion in the back, West Temple, that's Jurassic, Navajo sandstone. And if you swing it around, we kind of see a drop in the back there, and we see Navajo sandstone down here, actually quite below us. So we have rock of the same age at different elevations. That's an indication of a fault. This gives us a nice view towards Hurricane. Here we're staying on the high Colorado Plateau on Permian rock, about 270 million years old. And if you look down, you can see Jurassic rock, 180 million years old, clearly younger. So this area must have slipped down. Now the hurricane fault is about 5 million years old. It's about 250 kilometers long. The vertical offset totally is 2,500 meters. The Basin and Range province slips down with earthquakes. Slips can be up to 2 meters measured here. The last earthquake was here in 1992. It was a deep earthquake, about 5 kilometers down. Faults also form fault scarps, the actual fault line or surface being exposed. And so there is no fresh fault scarps in the area. The youngest one is about 7,000 years old. So earthquakes don't happen frequently, but they do happen, and they can happen at any time. It's still an active fault. We're back on Route 9, driving down the fault. As you learned here, a couple of different discrete parallel fault lines. We'll stop at one of them and have a little walk and close look at it. But as you turn around, you're going to see a nice fault scarp. Pretty much vertically, slightly slanted, flat, completely different direction than the horizontal sediment layers here. Here it comes up, it's nice, even a little glittery. That's the fault scarp or the fault plane there. We'll stop here down here. We've gotten out of our car and have a little hike, about 15 minutes. This hike is actually nicely described in one of Bob Beek's paper, which I'll attach as reference in the comments, so you can look at it in more detail. The slickensides you're driving by before, you can just see from here, it's to the left of the curve sign. It's what's called a conglomerate. We have rounded pebbles or rocks in a matrix what looks like limestone. Look at the top. we suddenly see a nice flat surface here. It's all flat. That's a slickenside. Close up, and you'll see a bigger, much bigger one as we go along. So slickenside occur in faults. It's friction between the two rock blocks releases heat. Heat melts just the top layer of the rock here. You can see striations here, here and here. That's the direction of the slide. A nice overview of the fault scarp with the Permian limestone conglomerate on top. Moine-Copy formation in red below. And it's a nice flat surface here again. Here you have a good look at the fault. You see this flat, nearly vertical surface. That's the fault surface where the red soft rock slid down along. You don't get slickensides all the time. There's need to have hard rock on both sides, so really rub on each other, generate heat and start melting the surface. Looking around, up here you get the slickenside, and you're going to have a closer look at it. We climbed up. I'm still huffing and puffing. The steep fault scarp. You see some slickensides, maybe. Well, there is one here. Just here, I see it's glistening here in the sun a little bit. The entire thing is a slickenside. The soft red Triassic mudstone, part of the basin. And here, the Permian limestone conglomerate. Pretty neat. Made it nearly up to the top here. Nice. The fault scarp, nearly perpendicular. And over here we have a beautiful slickenside. Look at this here. Beautiful slickenside, the fault plane here. Rock surfaces are melting and afterwards are solidifying into those nice glittery rock surfaces. That's called a slickenside. Just in case you didn't believe me, that's a slickenside. Now you see the reflection in some part of it. Here is another fault. So as I mentioned, it's going stepwise here. That's the reason the road is here. It's easier to build. Here again, Permian limestone. And here the scarp is kind of a little washed out. But straight ahead, some people are building houses on the fault. You like to live dangerously? Well, unfortunately, ignorance doesn't protect you from disaster. I hope you enjoyed this show, and I hope I'll see you at the next one as well. Thank you and goodbye.